I am Harper. I am an AI expert. I have about 10 years of experience in AI and machine learning. I have 2 degrees from Stanford in computer science, focusing in AI. I was at Meta, Facebook, and then Meta for about 4 years, where I was building machine learning systems. Um, and that was a pretty cool time. Maybe we can talk about that sometime. And then I was founding engineer at a startup with the two founders, and I uh, started teaching AI ML there, and I was making coding guides for fine tuning models. So actually changing the parameters of the model based on data. So it involves code, et cetera. And then that company was acquired by NVIDIA. And now I teach AI, and I started this about a year ago on Instagram. So expanding from the coding guides. So I'm so glad that you're here, and I'm really excited to start this Q&A series. This is my first time filming in my new studio for YouTube. So my new studio, this is my apartment. And welcome. I'm super excited about starting my YouTube, really, like having this be a consistent thing. I'm just gonna make the videos more casual, and I'll make longer form videos, and then, yeah, make shorter clips from it. So I'm just gonna go through, I have my phone here to just help me answer some questions. So the first question, oh, and I guess before I get into this is something that I'm going to keep doing, where I'm just going to make videos of me answering your questions, because I want to know what you are all interested in learning. And also, if you are interested in a one-stop shop guide to AI, sign up at the link that I will put in the bio here so that I can get your email and email you when it is out, because it will be coming out. You can also just subscribe here on YouTube, because I will also announce it. But I'm really excited about it. This is something that has been requested a lot, so I'm excited to finally share it. So first question, what happens to your data when you use AI tools? So it really depends on the tool that you're using. But if you are using something like ChatGPT or Google's Gemini or Anthropic's Claude, when you send info to the company, they store that data. So whatever you're sending them is now theirs. So if it's writing code for you, it is receiving the code that you send it, it is storing it in their servers because data is precious, and then they're giving you a response. There are some companies, like Grok, for example, which is a company that hosts AI models, typically open source models, and you can use their service where you can chat with their models through their website, but it's kind of closed access. But the reason I'm talking about this is that Grok does not store your data. So they've made it clear that their privacy policy is, hey, we will take your data just to run it through our models, but then we don't actually store your data. They've been very clear about that. If a company is not very clear about that, then they are indeed storing your data, and they're probably using it to make their models better. So this is where something like using open source models is really important. So what does that mean? Open source models are models where the code is readily available for you online. So you can literally take that model and host it on your own machine. So when you run it, you are actually just keeping it in a closed loop. You're not sending it out to another company's servers, another company's computers. They're not they're not the intermediary when you use an open source model and host on your own machine. There are indeed companies that host open source models for you, like Grok, where you don't have to set up the code yourself. They will host the models on their servers. But when you send your data to them, they, OpenAI, Anthropic, Google, save your data, unless they are very explicit about it, like Grok. So the benefit of hosting your own AI model is that you get to keep your data safe and secure. The only issue is that it can be kind of difficult to implement. However, there are tools like Ollama that make running AI models on your laptop easier than ever. So if you have an AI PC, like Dell's AI PC, which has an NPU built in, or if you have an Apple computer with an M1 chip or M2 processor, those chips can run AI models. Can they run huge AI models? No. Their compute is not large enough to handle some of the larger AI models. However, as I said, something like Ollama, which is an app that you can download onto your, say, Apple laptop, you can basically write a couple lines of code and then it will download models to your device. I think there might be some kind of user interface now, but there are apps like that where everything is just local on your device, and it allows you to download models, open source models, locally, and it makes it really easy. And so then you can work on your computer. The negative is that those models are not very large. They're not, and as a result, they're not very good often. So one of the things that you can kind of think of as a heuristic is that the bigger the model, the better it tends to do across all kinds of tasks. And yeah, so as a result, if you're just running it on your laptop and you're able to download a whole model on your laptop and run it, it is either going to be very slow or you won't be able to run it at all if it's like a moderately sized model. So I'm talking about like bigger than 7 billion parameters. Even 7 billion might be difficult on a laptop. And when we talk about parameters, we're talking about like, if you hear of open source models, you hear like Llama 70B, Llama 7B, Mistral 7B. That's how many parameters, that number at the end is how many parameters are in the model. And the parameters are kind of like the number of neurons in the model's brain. And if you have more neurons, you can basically hold more data in those neurons. So like when I say data, I mean like more information. Like the model's brain is more complex. It can encompass more of the world. And yeah, as a result, bigger models tend to do better, at least with these models that are trying to capture everything in them. I mean, one of the interesting things about these foundational models, so foundational models are models when that just hold everything in them. So like they're like Llama or ChatGPT or Anthropic. They're just like models that are large language models specifically. And large language models are models that output text. So large language models are text generation models, and they can be augmented with the ability to like search the web. But at their core, large language models are text generation models. Foundation models are these text generation models that are really good and they cover everything. And they're trained on all the internet from all the data from the internet, basically. So all these foundational models encompass basically all text from the internet. And that's why that's what we mean when we say foundation models. So on this topic of foundation models, I'm mentioning this because I think some companies and some people use these massive models when they don't need to. And so there's actually a lot of cost saving potential. And so here's what I mean by that. So if you have a very specific task, say you are classifying emails as scams or not scams. So people are emailing you and trying to steal money from you via various different types of scams. I'm sure you've gotten one of those emails before. You could use a very expensive, massive model that is a PhD in thousands of different topics and knows about all of the world and knows everything, basically, this massive super brain, or you could have a very specified model for that. Why pay for this massive super brain for such a narrow task? A sunk cost, and then you get to shift and move towards using open source models and fine-tuning a narrow specific use case for your model. So the benefit of this is, one, it doesn't need to be a massive model. So we talked about how you need really complex compute for some of these massive models because it needs more memory to hold. If it has 400 billion parameters, it's going to perform very well. It's going to be a model that knows all about the world and can do a lot of tasks. But you don't need that if you have this one specific task and the brain can be 100% focused on that. You don't need 400 billion parameters. 400 billion parameters encompass the entire universe of possible things that it could do. So think about what a tiny fraction of that you need to accomplish one specific task. And so that is really exciting. Oh, there, I got a package. Let me say hi. Thank you. So that is when you think about that. So then you can fine tune this model. You can have your data samples. You should learn about data. I have a video, 10 Days of AI Basics on data and pre-processing and making sure that, you have the right balance of your classes, etc. So if you want to fine tune a model, I have a lot of resources for you here, and also comment if you're interested in fine tuning a model. I want to know. But yeah, so I recommend in a lot of cases fine-tuning a model and having a very specialized model for your use case, because then you are free from having to pay for these massive super brain models that you don't need. And someone could argue, when a new model comes out, you lose the ability to, if you have a fine-tuned model and a new model comes out, like a new foundational model, then you have to refine tune. Like it's fine tuning as a process doesn't just transfer over. You would have to fully fine tune the next model when it comes out. But what I would say to that is like, again, okay, yeah, the model does a little bit better, the superbrain model, but is it better at the specific task that I have fine tuned my model to do? I don't know. If it is, and it's an open source model and I can fine tune it, then maybe it's worth fine tuning again. And again, as I said, in the case of scam detection, it's this adversarial situation where, they're going to keep adapting. So you would have to kind of frequently update your model, frequently kind of tweak the parameters, fine tune, add more examples. But in a lot of cases, you don't have to have this constant updating. And like if it has a specific task and this task isn't constantly changing, I mean, you can expect that you're going to have to adapt your model over time. And there's some heuristics that you can have to kind of trigger when you should fine tune your model again. For example, if you find that the model is not doing well based on its interaction with users, if the accuracy starts to go down, or maybe you just have a time-based trigger where like every 6 months you want to fine tune it again, that kind of thing. So you will need to adapt the model over time. But again, I really think that fine tuning narrow AI is such a way that people can save money and use like less intense compute for their specific tasks. But if you're doing something like just working with a large language model, like if you have a chat bot or something and you want this kind of jack of all trades model, then yeah, of course, using a foundational model and using the best foundational model available, as in the largest number of parameters, typically tends to do very well. So that kind of gets me wanting to talk about mixture of experts models. There's like so many little things I could just like blab on here. Okay. So mixture of experts models, they are models where they are composed of separate experts. And let me just like back up for a second and talk about why this is important. Like why I would even talk about this. So one new-ish update, kind of architecture choice that is happening in the large language model world is companies using something called a mixture of experts model. And DeepSeek used it and Llama used it, recently Facebook's Llama. And basically what it is a way to have a very, very intelligent model run very quickly. And so to kind of speed up the brain of the model. And so what it does, what this mixture of experts model does, how it works, is that it is composed of separate experts. So kind of like what I was talking about before, we have like a very specialized model here, where the scam classification model. Mixture of experts models might have like 160 experts in them. That's an example from Meta. I think their newest one of them has 160 experts. So they are, distributed across 160 different like topics. And again, this is like the whole world fitting into like 160 topics, but each one is specialized. And then they're all mashed together. So the Llama, I think Llama 405B encompasses the parameters of all of those expert models, plus kind of like models where they all go through. Sorry, I just got confused. I just got a notification. I should turn my phone on Do Not Disturb. When data comes in, so when you send your data to the mixture of experts model, so for example, you're chatting with DeepSeek or you're chatting with Llama, it receives your information, your input, as a series of tokens. And if you don't know what tokens are, they're basically fragments of text. You can kind of think of it as like per word, but it's technically like fragments. It might be like the plus a space, or like partial parts of words, kind of like Latin subroots or something. But tokens are words broken down. And so it receives for each of these tokens, the expert determines, or the central brain, it's like a core brain, which is separate from the experts. There's like one core brain that receives each token as it comes in one by one, which, if you don't know, is actually how large language models work. They process each token one by one. And that's why you might see when you're working with a ChatGPT or something, it like comes out like that. It's because it's processing one token at a time and outputting one token at a time. Or no, it's processing all the tokens from before and then outputting one at a time. And so it's like all the tokens up to the next token. So it's like taking 0 to n -1, and then it outputs n. And so then at the next one, it goes 0 to n, and then it outputs n+1. But anyway, sorry, a little side note. Basically, as the data comes in to this mixture of experts model, there's a central brain processor that chooses which of the experts to use. And it might choose a couple, or it might choose one. With Llama, it chooses one. And then that model outputs that token. So for every single token, it chooses a different model. And so it's faster because you only have to go through that one model. So you're going through a fraction of the total number of parameters. So again, if we have something like Meta's 405 billion parameter model, and there are 160 experts, it's not perfectly evenly distributed. And there's also some parameters that all the models share. But like, that's about 3 billion parameters each. So that's like really small compared to 400 billion. So it actually only has to go through about 3 billion parameters, maybe 5 billion, whatever. But it's tiny compared to what it would have been before. And I'm sorry if my numbers are off with Meta. If it's not 160 experts, maybe 116 or something, but it's over 100. So anyway, so it's much faster. However, you still do, my dog just scared me. However, you still do need expensive compute because you still need the entire 400 billion parameters loaded onto the model's brain at any time. Because again, for every token, it's choosing a different expert. So theoretically, you could choose like all 160 experts really quickly. Like you could have 160 tokens and then choose 160 experts. And each token is processed so fast that you're going to need all of them loaded at once into the model's brain. But it actually only propagates through maybe 3 million billion parameters rather than 400 billion. Does that make sense? So it's choosing, again, a portion of the model, and then the input propagates through that portion. Because remember, AI models are really just mathematical equations. They're just a series of equations that the input then is processed through. And so is it processed through an equation with 400 billion parameters, or is it processed through an equation with 3 billion parameters? So again, it's the compute required to process that and the amount of time it would take to do that mathematical calculation greatly reduced by choosing only a fraction of the whole possibility equation. So let's see, we really talked about a lot of things going from what happens to your data when you use AI tools. Okay, why can't AI just browse the internet like you? Okay, so this is a common misconception that large language models all have the capability to browse the web. That is not true, my friend. At their core, large language models are text generation machines. They are just generators. Given the input that they have received, 0 to n-1, they process and then output the nth token. Okay? So, and I guess as I'm saying that, I realize what that means is like, if you say to the model, hi, my name is Harper, it will process the first round, it'll say, hi, my name is Harper, and then it'll output hi. At the next round, it'll process, hi, my name is Harper, hi, and then it'll output my. And so its response, say if it wants to say, hi, my name is ChatGPT, it will go, hi, my name is Harper, then hi, my name is Harper, hi, then hi, my name is Harper, hi, my, then hi, my name is Harper, hi, my name. And so it's with every output, outputting its own response into the model as well, into its own process as well. So again, it's like this sliding window of text, and for every token generated, it's looking at all the tokens before, including its own tokens. And there's a limit to that, how much that window can hold of what it considers when it's outputting a new token, and that is called the context length. So if you have heard of that before, that is what that is. It is the length of the context, and the context is the amount of information the model can store in its brain at any one time. And some of these bigger models have gotten, longer and longer context lengths. The actual effectiveness of the context length, like some of them have crazy long context lengths, like millions, and whether that the actual length of the context, so the actual effectiveness, so like, okay, a model might say it has 1 million context length, but then if you actually use 1 million tokens, you'll notice that the model can't actually recall information from, the first 1,000 tokens, or maybe even further than that. And that's because like these context lengths are actually subject to a lot of other factors, and it's compute and things like that. So it's not perfect, but that is the idea: is that the context length is the amount of info that the model can store in its brain and refer to at one time. Um, and so, what was I saying? Oh, so AI browse the internet. So AI can't browse the internet because it's just a text generation machine. The models that browse the internet for you and retrieve information from the internet, that is an augmented capability. So that is an AI showing agentic capabilities, meaning it's able to actually like take actions in the world. Again, because large language models, these text generation machines are simply text generation machines. That's all they do. Based on their input, they output new text based on the probability distribution of the input that they received. Searching the web is not that. Searching the web is a separate capability. And so some of these models are augmented with the ability to search the web and then load that data that it finds from the web into its context, into its working brain, and then reference that. And so that's how you see some of these models working, where they like output references, is they've added the capability of, okay, let's write some code that will then search the web. Let's grab the first 5 articles, stick it in the model's brain, and then let's have the model in the model's brain is in the context, in the prompt. So they're secretly stuffing a few web pages into the prompt with your own prompt, but you just don't see it. It's behind the scenes. They stuff in these websites and they say, okay, model, respond to this user's input and reference, these 3 articles that we just found off the web. So that's what's going on when a model is searching the web and referencing it. And you might find that a lot of these models actually don't do very well with their references. So this is where we could probably talk about model hallucination and some issues there. So as I said, models are just text generation machines. They generate text based on probability distributions, meaning of all possible words, each word has a certain probability of being chosen, and then it just samples from that probability distribution. So for example, if you have the phrase cat in the next word is perhaps 90%, there's a 90% probability of choosing hat. But then there's a 10% probability of choosing 1,000 other words. And so 90 times out of 10, it might choose hat, but 10 times, 90 times out of 100, it might choose hat, but 10 times out of 100, it'll choose any one of these other words that have a probability. Say, I mean, there's tons of other words that could be chosen, but say, just to make this simple, say the only other 10 words, the only other words that could be chosen would be cat in the house. Let's say house had a 5% probability, and in the bathtub had a 5% probability. Imagine there were only 2 other words, okay? And they each had a 5% probability. So 90 times out of 100, the model would say hat. 5 times out of 100, it would actually say house, cat in the house. And then 5 times out of 100, it would say cat in the bathtub. And so it's this probability distribution where it is sampling from this probability distribution where all the words that it could possibly say have a certain probability of being chosen. And then it just grabs from that. So it's not always going to choose the most likely word. It could choose a word with a very small probability, just based on the fact that sometimes small probability events occur. And so how this has to do with hallucinations. Hallucinations, if you don't know, are when models make up. So they just literally make things up and they say them with confidence. There's a bunch of reasons why hallucinations happen. One of them is, of course, the fact that the models don't actually have at their core, if they're not like specifically linked up to a database or to the web, which is an augmentation of large language models, but at their foundation, large language models, again, are just text generation machines. They don't know what is fact and what is fiction. They're just outputting text. And so they might choose a word with a low probability just based on chance and then just kind of run with it. And so if they said like cat in the house, then they're going to say, okay, cat in the house. And then they're going to go down this cat in the house direction, even though we were really supposed to go down the cat in the hat direction. Because of that small probability, it chose cat in the house. It's like going to run with that because it doesn't know that's wrong. And if you get into areas where there's more ambiguity, so there are some kind of safeguards on this where they really heavily skew towards the most likely word. So it's very unlikely you wouldn't choose hat and then go down like a random tangent. But there are still cases where it would hallucinate, for example, where it doesn't really know what the next word is. And when it's making things up, it's kind of like, you know, the distribution of possible next words is like pretty even. And it's like, I don't really know where I'm going to go. So I'm just going to choose. But the model doesn't think I don't know where I'm going to go. It's just sampling. And so just makes things up. It just samples a word, then it sticks with that. And then it samples from the word that it just chose. You know what it's kind of like? It's kind of like those poem things that we would play in school where each person would write a sentence or even just a word and then pass it to the next person and then pass it to the next person. It's kind of like that. It's like it's chosen a word and now it's like, all right, this is the path that I'm on. What's the next word? And it like updates its probability distribution of next words based on the word that was chosen before. And if a kind of random and unlikely word is chosen, then it's just going to go with it. It's just going to like keep going from there, kind of like those poems we did in school. You just kind of went with it. It's like improv. Um, and again, it's not checking anything against facts, so it doesn't know. And so you really have to be careful about these models making things up because they do, because they're just word generators. And so some ways to mitigate this are, again, with like searching the web and then sticking that info from the web into the brain to have it reference like recent data specifically, like into the prompt, right? Or to have it reference a database where it kind of like, given the prompt you give it, it searches the database and finds most likely what the prompt that you've given it is referring to in the database and then sticking that info in the prompt as well and then running the model. And so it's really just like adding info to the model's brain and then to the working memory context to generate new outputs. Okay, let's see what's next. And if you have any questions about any of this as I'm going through this, please comment. Please let me know. Okay, when you ask ChatGPT a question, here's what actually happens in 30 seconds. So we kind of covered this a little bit. When an AI model, when you are chatting with ChatGPT or Claude or Gemini, and you send it your prompt, it receives that block of text that you sent it, and then that block of text is transformed into number form. It turns into tokens, so it's broken down into individual tokens, which, as I said, are kind of like word fragments. And those word fragments are then mapped to numbers, basically like each word in the dictionary. Say there's 10,000 words in the dictionary. It would then, and then every word is labeled like 0 to 1,000. And then you would just map like, okay, the is word 1,002 and A is word, 1, And so every single token is mapped to its number and every single word is mapped to its number. And it makes this kind of number that is then processed through the model. So the model is, as I said, this series of equations. They are matrix multiplications. It is mathematical equations that the input, which is originally text, but then transforms into numbers, then goes through these mathematical processes and is multiplied. There's some numbers added, and then you get this output. And it's this distribution, this probability distribution across all the possible words. So again, it's like of those 10,000 possible words in the dictionary, each one has a probability. And then the model chooses samples from that probability and gives you the first token of its response. So you say, hi, I'm Harper, and it says, hi. It's processed, hi, I'm Harper, goes through, turns it into tokens, it goes through all the equations, it maps the likelihood of all possible tokens to respond to probabilities, and then it samples from that probability and it gets high, because maybe that had a 99% likelihood of being the response. Then it goes again, takes in, hi, my name is Harper, and then hi, and also probably a token saying that we've switched from user to chat. So maybe it's user, hi, my name is Harper, chat, hi, and then process that, go through, turn it into tokens, go through the entire process again, create an output. And there are now some tools like caching, like memory caching, where you can kind of save all of the memory, save the equations from before, like up to the most recent token. So that helps go a lot faster. But yeah, it's literally generating one token at a time, one word at a time, one fragment of a word at a time. And then it does that over and over and over and over again, which is why we need so much compute. And another thing I want to say is a lot of people are kind of up in arms about the environmental impact of AI and the compute that it requires. I just want to quickly talk about that. There was some data that came out about 6 months ago, maybe longer, that said Google AI searches use about 10 times the amount of compute as typical Google searches. So people were very upset about that. However, a new study came out about a month ago that said Google AI searches now use 1/10 of what they used back then because of improvements in compute. So compute efficiency has improved. How? From AI. AI helps us improve the efficiency of our processes. It helps find those optimizations to improve efficiency. So yes, AI requires a lot of compute, but AI also helps us find more efficient processes. So that, the fact that it uses a lot of compute now doesn't mean that it always will. I mean, think about like X-rays or like old medical systems used to be these massive machines that were just like crazy and, so expensive and so just like gargantuan. And now, because of improvements in design and efficiency, they've been able to become much less, energy intensive and much more affordable and help so many people. And so it's going to be like that. But with AI, we find these improvements so much faster because that is what AI does. And I think a lot of people have only see AI as large language models, but AI at its core really is this optimizer. It is, large language models, for example, it's just outputting text in the optimal way based on what you've given it. It's this optimizer for text generation. But AI at its core is like finding the optimal point, and it can find inefficiencies and it can improve those inefficiencies. And so when AI is applied at scale, not just as large language models, but as any kind of data analytics tool, any kind of like data processor, analyzer, that will be able to cause improvements in efficiency across so many areas, including energy, including climate. I mean, we are going to see so many extraordinary advancements in the world. And one thing I like to talk about here too is the idea of AI being the ultimate polymath. So a polymath is someone who is an expert in a variety of fields. In history, it's been, maybe 2 or more fields, 2 or 3 fields. Thomas Edison, Nikola Tesla, they were polymaths because they were experts in about 2, maybe 3 fields. Okay. They had massive improvements to society, to the world, because of their very unusual ability to find correlations between 2 distinct areas, and were able to take that synthesis and create something extraordinary. Now we have AI, which is an expert in thousands of different topics and able to find correlations between those topics. It's on it by its own, on its own. And the reason it's able to do that, and oh my gosh, this is just so fun. Now we're getting into emergence and emergent behavior. So the fact that it can find correlations across distinct fields shows it is not just outputting its data, because it is finding novel insights. It is able to find these correlations between 2 different fields that have never been present in its training data. So it is showing emergent behavior. It is showing capabilities that were not given in its training data. This idea of emergent behavior is new for large language models as of the transformer. And the transformer is a type of architecture that came out in 2018. And that is new. The idea that large language models are showing behavior and thinking kind of in their own way and outputting data that is not in their training data, outputting novel insights. That is emergent behavior, and that is new to large language models as of this new architecture called the transformer. And I have a video on the transformer, and I will link it here. I don't want to get into that right now, but it's basically just made models so much better. It was a very large reason why we were able to now have models like ChatGPT, because before the transformer, the models were not as capable as they are today. And so this idea of emergent behavior is really interesting because it also goes into it debunks the idea that AI models are simply, outputting data that they were trained on. So like they are not capable of thinking for themselves. They are just 100% stealing artists' work. No, actually. So it's different if you say like, let's look at image generation models, okay? If you say like output an image in the style of like Dali, like the artist, not the image generation model, it will zoom into the part of its brain that knows about Dali and then output from that. So its probability distribution has now completely shifted from its general big brain probability distribution to zoom, Dali. This is what I know. And so every token pixel it outputs, so its own tokens are kind of just like pixels, colors, it outputs will be in this probability distribution. It's zoomed in. But in general, in its big brain self, it encompasses everything. And so it's not just stealing, like not everything it makes is like stolen from some random person. It is the amalgamation of everyone. It is like a human brain in that sense. It is going about the world, it is taking everything in, and it is creating from what it has learned across millions of examples. And so the reason I'm also talking about emergent behavior here is that it is literally proven that the model has novel insights. So like I would say, even if we didn't have emergent behavior and you were just having the model like generate an image of like a cat, it'll look at in its brain, if it has thousands and thousands of images of cats, it will consider all of those. And that's kind of a bigger world in its brain than like of Dali, you know? So like the more broad the prompt is, the more general and less like likely to be directly stealing from something it is, because it's considering all of the data in its probability distribution. And so then, you can think of it as like any one piece of data or sample image of a cat is less likely to influence the entire thing if it has lots of examples of a cat. Its cat output is likely to be novel in that case because it has so many examples to choose from. And so many different styles, like think of just the world of cat images. It's crazy. There's so many different, there's images of cats, there's paintings of cats, there's memes, there's like a million different worlds of that versus like choosing, the portfolio of an artist where it has maybe 100 pieces of art, maybe less, So again, you have to think about like what you're prompting the model to do and the universe that it has zoomed into based on your prompt. What is its like brain, like how much is in that portion of its brain? Is it super narrow or is it super large? And with emergent behavior, knowing that the model can then output something it's never seen before, it's then obviously not just stealing everything. It's coming up with new novel ideas. It's finding these correlations that we've never seen before. So that's what I would say to that in terms of the, argument that it is stealing, just purely this like stealing copycat machine, because that's just not the case. Well, there's still so much to say, and I think this was a fun first episode of the Q&A. And so let me know in the comments how this went for you, if there's anything that's still unclear. My job is an educator, so if anything I said wasn't super clear, that's on me, and I want to learn. And so yeah, feel free to give a comment and help me become a better teacher. So I hope this is helpful. Send to your friends and like and subscribe. It helps me so much. I am so excited to be doing this, and your support helps me keep doing it. So I'm just really happy you're here, and it means a lot. And I'm excited to be doing this with you guys. So yeah, let me know how this went. Leave more questions for me, and I hope you have a great day. All right, bye.